So, welcome to this course, Scientific Computing in Python and Fortran. So today I will go through some of the introduction material to the course, but also start with the first parts of Python. So my name is Jonas Lindemann. I work at, day work is as a director at LUNARC, the Center for Scientific Computing. But I will tell a bit about my background as well here. So let's see if I can move my slides here. So I have programmed computers since the 80s. Started with a Swedish computer, ABC80, went on for a larger one, ABC800, so that was C80 based. I had a home computer which failed. I went over to Commodore 64, Commodore Amiga, and then PC. I'm also a civil engineer at Väg och Vatten, so I have a background at LTH. I worked at the university since approximately 98. I have a PhD in structural mechanics. And I worked at LUNARC since 2003, building high-performance clusters, storage systems, visualization systems. So that's kind of my work background. So also scientific computing nerd. I really like scientific computing overall in most languages. So I don't have any preferences for languages. And you will see I have programmed a lot of them. And I started in the beginning with Object Pascal, was my first kind of big language on the PC. Then I saw kind of a light that Object Pascal was not a standardized language, so I switched to C++. I've also done Fortran since 98, and that was when I started as a PhD student, started working with the computational codes. So I did some modernization of Fortran codes. Java, but that's very little. I did some smaller projects, not really used that much in scientific computing. Python I started with actually after my PhD. So my supervisor, he commented like, "Have you tried Python?" And I was, all my work in PhD was C++. And he kind of turned my eye that this could be interesting. So I've used Python since 2x and 3x since 2003. In my hobby time, I also do something called creative coding and this environment called processing, which is a simplified Java environment. Really fun. I will have a lecture on object-oriented programming done in processing, so you can show that as well. Very limited JavaScript, but some. I developed a couple of software packages. ForcePad is an application I did in my PhD, which is a two-dimensional finite element code with real-time interaction where you can see the forces in real time. Same thing with Objective Frame, that's a three-dimensional frame application, which you see some user interface there on the lower right. I did some interface to kind of combine Fortran with Windows. So I did an interface wizard to generate the binding code between Fortran and Object Pascal. I've done a graphics library also in my PhD work for OpenGL based. I also worked on the structural mechanics Colfem package, which is a MATLAB based package for finite element code teaching mainly. I did an application portal for LUNARC. And then also the biggest thing I still work on is the Colfem for Python package, which is going to be used in teaching at structural mechanics when we switch to Python. Some more here. One thing, if you use the LUNARC systems, the GFX launcher is something I developed to start applications interactively on our desktop. ML Browser is an interactive user interface for actually looking at the module tree, the software packages on the LUNARC systems. And also I've been helping out with a simulation code we had developed at Structural Mechanical called Hakon, which is simulation code for hardening concrete. Qt Creator Fortran extension is something that I hope you use in this course later on, which is an add-on to Qt Creator that you can compile Fortran code easily in that environment. And there are some other things here as well. I also did a sign for our motocross track in Skivarp. So why this course? So if you look at the description here, is a course intended for students with basic knowledge in programming to learn the techniques of scientific programming. And in that we will cover Python, but typically with NumPy modules for numerical codes, but also for data handling, data processing, visualization. We'll also look at ParaView for visualizing data, how you can create code in Python that generates data that you can export to ParaView. We will also go through an introductory part where how you can implement user interfaces in Python as well using Qt. And then we also actually look at the Fortran language as well. I will teach modern Fortran in this course. So this course will not cover Fortran 77, only the connections to Fortran 77. So if you've seen Fortran 77 code, modern Fortran is quite different. And I will show you how different it can be, and we'll come back to that later. And also how to use it as an extension language for Python. So it's very easy to combine Fortran with Python. And this will go through in this course as well. So that's part of the mixed language program with Python. So some examples here, what you can use when you have done this course is automating workflow. Use Python as a scripting language to automate all your scientific tasks so you can reproduce your results. Of course, use Python as a tool for numerical computing. Use the libraries NumPy, SciPy, and Matplotlib as a research tool. Data management and processing. So how to use Python to read and write process files in your workflows. Some visualization here as well. Use libraries such as PyVTK to export data to visualization tools such as ParaView or Beto. And also finally, modern Fortran as a tool for numerical computing. So first of all, we will learn how to build standalone Fortran applications, and then also modules for using that together with Python. And implement reproducible scientific environment in Python as well. So just go through kind of visual of what can be. So this is typically environment here in a notebook where you do computing with arrays using NumPy. You will also learn how to implement user interfaces in Python and Qt. So here's of course, this is from my background. So this is a continuous beam with loads and how it deflects over the beam. And it shows the forces inside the beam as well, and also numerically a table here. So some of this you will learn in this course as well, how to go to implement user interface to your own codes. And that is also part of the project thing you can do as well, to use some of the concept in this course in your own scientific research. Visualization, this is some of the things we will be doing as well. Use ParaView to kind of produce images like this from data. So going from Python to a file format that you can import in ParaView to finish visualization. We'll also do some object-oriented programming. This is on the left side is the processing tool here I will use as an example to illustrate the concept of object orientation. Modern Fortran is an example here how modern Fortran can look. And you can see here already that it's very similar to how you do it in Python and NumPy, and also MATLAB. You have here you have, for example, let's see if I can do with a pen here. So you can see here you can have same notations as in MATLAB for selecting columns and rows. And you can also assign things on single rows here. There are functions here for matrix multiplication, transpose, so that is built into Fortran itself. It's not as nice it doesn't support expressions of arrays directly. You can, of course, implement it because Fortran today is an object-oriented language. You could actually implement a library in Fortran that can do matrix multiplication as well with expressions. So this is modern Fortran. Also on a high level here, I want to show you this map here. This is the course laid out. So the first thing we will start with is, of course, Python here. We will continue on to Scientific Python and Matplotlib. We will use PyQt and Qt to look at user interfaces in Python. We will look at visualization here using PyVTK, ParaView, and VTK. Then we will do Fortran, which contains the basic language of Fortran, also how you build and maintain Fortran using CMake and Make. Also how you use the Qt Creator development environment to compile and build Fortran and debug Fortran code as well, but more graphical way. And then we will look at mixed language programming here, how you can combine Python with Fortran and use Fortran as an extension language to Python to accelerate your Python code. So course modules here, we are at the first module here, Introduction to Python, which I'll cover later on in this lecture. We will do matrix computing with Python, plotting with Matplotlib, built-in functions and I/O. So we will go through the Python runtime library and see what functions are already built into Python, so you don't reinvent the wheel all the time. Object-oriented programming in Python. The reason is here because Python is a fully object-oriented language. You can use it in different modes. You can use it as function-oriented. You can use it as an object-oriented language and kind of a hybrid. But it's good to know what the underlying concepts are, because everything you do in Python is an object. And then you can extend those objects in different ways as well. We will go through data processing and visualization. So how you read data in Python, how you write data, and also how you export data from Python. We will do user interfaces in Qt, maybe nice GUI. I'm not. It will be an optional task here. If you want to write web applications in Python as well, you can do that using the nice GUI. But the material is a bit not ready yet. But if you're interested, you can do the exercises assignment using this toolkit as well. And we have Fortran and mixed language programming. And there will be short assignments for each module. There is also, at the end of this course, there will be a project assignment. And you can either use a project assignment that I give you. So I have a proposal for what you want that you can do if you don't have any ideas. But the best thing if you try to define a project within your own research area. So combine some of the things in this course with your research and formulate a project. I will get back to that later when we come to that point. So we have lectures on Mondays and tutorials on Thursdays, but this first week will be only lectures. So the first tutorial is next week. Also, please look at the calendar, because there are some, it's not every Thursday we start at 10, because the bookings here, so I had to change. But so have a look at the calendar for the times of the different lectures and tutorials. Course administration. So we will use, I will use all Canvas throughout this course, so all communications through Canvas. And also all the assignments are turned into Canvas. Also, I will try to answer comments through Canvas as soon as possible. Can be some delays on this here, so I hope I will do this as quickly as possible. And now I will come to the kind of parts that is not so nice to cover here, but the projects here are individual, so you turn them in yourself. You're not allowed to share program source between you when you turn in your assignments. Generative AI is not allowed to generate text for the reports. So if you write your project report, you have to write your text yourself. It's not strictly forbidden to use generative AI tools to aid in coding tasks, but you have to understand the code it generates. And also, we will kind of test your knowledge in the assignments here as well to see that you understand your code. There is a complete page on this here on the Canvas page as well. So please look at that as well. Course literature. There is a web page for this. I will show you that contains all the materials you need. There are some things you can look at here. How to think like a computer scientist. There is also a course in Python that you can use, which is excellent. There's a NumPy guide here as well. That's web-based. If you know Swedish, there is a Python book that I've written here called Ingenjörens Guide to Python. There is Learning Python, there is Programming Python, Python Script and Computation Science. Strictly, I mean, you can use those books, but I think you will manage with the web-based material quite okay. So let's see here. I'm just going to